What up, 2 Live crew? That's right. Well, you can't ride with that because it doesn't work like that. Don't know why I'm singing what I'm saying, do you? All right, what I want to talk about now is logical reasoning. Boxes are in right now, guys. Box in all your words. Okay, so the first thing we're going to look at is conditional statements. If something is a conditional statement, that means it has conditions. It depends on something. Like, if you hear in the movies, they're like, we're going to send out the hostages, but here are my conditions. That means I'm going to do something for you, but it has to rely on something else happening. Okay, so conditional statements. One of the most common conditional statements you hear are if, then. Okay, I don't know why my hand just went weird. I'm sorry. Okay, some, if then statements mean if blah, blah, blah happens, then blah, blah, blah will happen. So, for instance, you say, if you clean your room, then you get money, brah. You get paid, okay? You got if, you got then. All right. Now, in an if-then statement, it's essentially split up into 2 parts. Your if part and your then part. Your if part is called your hypothesis. Okay? It's what we're saying, just like in science, you say a hypothesis means like, oh, I wonder if I try this, what's going to happen? That's essentially the thing you're going to do. And then your then statement is your conclusion. Okay? That means if you do this, then this will happen. If we clean our room, then we going to get paid. Homie want to get paid. And by that I mean, I should probably never use the term homie again because I don't feel like that was comfortable coming out of my mouth. I cannot remember the last time I said homie, so I apologize. I'm really sorry. I didn't mean to use a $sign like that, and I feel like I disrespected the $sign when I said that. So how about this? Can I say it again? Restart. If you clean your room, then you're going to get paid. Paid. You might get played too. A lot of people's money get played a lot because they got money. People play them. You're learning a lot more than math today, everybody. You're learning about life. Okay, so hypothesis, conclusion. If we clean our room, then we're going to get money. All right? Let's try it with the math version, okay? Let's say if... Let me see. Don't lose your patience, child. 4x plus 7. If 4x plus 7 is greater than 27, then what? Well, I don't know. Let's work it. Let's see. Subtract 7. That's 20. Divide by 4, so it's 5. Then x is greater than 5. Okay? Cool. Now, if this is true, then this has to be true. Well, let's see. We got 4x plus 7. We subtract 7 from both sides. We got 20. Divide by 4. It's 5. Well, if that's true, then that's true. Maybe a better example would have been this. If this is true, does that mean this is true? If our x is greater than 5, does that mean our x has to be greater than 6? Or does that mean x is greater than 6? Not necessarily. It could have been 5.5. Okay? So, that brings me to my next point. It's called a counterexample. This is one of my favorite terms because it's just so easy to explain. A counterexample is something that proves it wrong. If that is that, then that is that. Correct? Sure. Well, what about 5.5? 5.5 is greater than 5, but it's not greater than 6. It works here, but doesn't work here. It proves our conclusion incorrect based on this hypothesis. Okay? That's a counterexample. Awesome. Counterexamples are awesome. Because it's like, you're like, here's something that's true, and then somebody's like, but-ow! They deflect it. That was a horrible deflection. Like, I don't know who was shooting it, but I was like a marker hand. I feel like what I should have done was gone catch, throw it up, sign it, and then punch the basketball back to the other court where Michael Jordan, my best friend in real life, catches it and dunks it. Didn't know that we were best friends. That's okay. It happens. A lot of people don't know just because he doesn't tell anybody and I don't tell anybody because it's not true. Okay. Cool. Okay, so let's look at deductive reasoning. Deductive reasoning. Okay, I don't know if you learned about it in algebra, but in Inductive reasoning means that you're looking at patterns. Deductive means you're using facts and logic to solve a problem. Okay, so in this problem, if we're using deductive reasoning, let's say that it is if you have two odd numbers, their sum is even. Okay? Alright, so my hypothesis is you have two odd numbers, and the conclusion is the sum is even. Okay? So in deductive reasoning, essentially I would take an answer saying the two numbers are 7 and 3. Are those both odd numbers? Yeah. Okay, well good. Well then I would put it together and see if it is correct. So I take this and I figure out if this is true. Two numbers are 7 and 3. Those are two odd numbers. 7 plus 3 equals 10. Is 10 an even number? Cha! Every day of the week almost. That's correct. Okay? So I use my deductive reasoning to say, oh, these are correct for this. I use facts to lead to my conclusion. Okay? And that's the simple version of deductive reasoning. I've also got a video on deductive reasoning that focuses a little more in depth. But that's pretty much that. So, cool! You just learned. And it felt great.
Hello. Thank you for coming to Tarver Academy. Please subscribe, maybe